Very straightforward because it's one of those terms that actually kind of defines itself. Any value that's, of course, this is what you'd be thinking, any value that's outside the range of Q1 minus 1.5 IQ. No, it's an outlier conceptually is a value that lays or lies outside of the overall grouping of the data. All right, so I think I gave an example, maybe it was yesterday, like if you had a group of high school students and you polled all of those students on their ages, you get a lot of 15, 16, 17s, 18s, teens. If you saw a 75 in there, you'd be thinking, okay, that's probably a mistake. So a value that is probably a mistake is most likely going to be an outlier. But we do have a mathematical way of computing outliers that we can do straight up on Desmos, and we could also do on the TI calculator. All right. It requires us to find the quartile values. Now, when you're looking for quartiles, all you're doing is finding the median multiple times. So I glossed over the by hand approach for doing a lot of this stuff yesterday, but I'll just do it really quickly. If I'm looking for the median of this data set, I would work from the outside in, just counting numerical values until I get to the center. So I just work my highlighter in, and I'm either going to get one or two values in the middle. If I get one value, then that's my median. All right, you should have an equal number of values below your median, numerically less than your median, as you do above or numerically larger than your median. All right, so the median here is 7. All right, but then what you would do is find the median again, but this time for the lower half of data. All right, that's going to give you the lower quartile, or Q1. That would be the first quartile. But you're going to apply this concept of the median again, just counting into the middle. All right, so I'd work my way in, but you'll see that there is no value that's directly in the center of the data. All right, so what we would do is find the average of these two values, and that would be my lower quartile, 4 plus 5 over 2. Obviously, you can do that in your head. I don't think that's speaking out of turn there. I think that's pretty obvious. But yeah, I just show the work so that you know what the skill was that led to that. But then using that same idea, I could find what's called the upper quartile. All right, UQ, or Q3 is going to be the average of 9 and 10. You might say, what happened to Q2? Well, that's actually the median. All right, the median is also Q2, the second quartile. Because if you're counting in quarters, a quarter of the way, 2 quarters, 3 quarters, and then all the way. All right, so 1 quarter, 2 quarters, 3 quarters, lower quartile, median, upper quartile. All right. So then to find what's called the IQR, or the interquartile range, IQR is going to just be simply the difference between the upper and lower quartiles. All right. So this is the UQ, and this is the LQ. Then you just pop it into this formula and you're good. All right, it's a domain. All right, you think about domain and range, interval notation, brackets, parentheses, brackets include the value, parentheses exclude the value. All right, so these are brackets for a reason. Q1, 4.5, minus 1.5 multiplied by the IQR, which is 5, comma, UQ, which is 9.5, plus 1.5 times the IQR, and then simplify, and you'll get your values. All right, 1.5, 1.5 of 5, 1.5 times 5, it's going to be 7.5. So 4.5 minus 7.5 is negative 3. Then 9.5 plus 7.5 would be 17. All right. So what this gives us is the interval of non-outliers. So any value that's contained between the -3 and the 17 is not going to be an outlier. Anything that falls outside of that interval will be an outlier. So you go through your data set and you say, okay, does 2 fall in that interval? Does 4, 5, 6, 7, 8, 9, 10? No, but 42 does. Oh, I'm sorry, 42 does not fall in that interval, so 42 is an outlier. All right, bless you. Now, in statistics, we don't just eliminate an outlier because we feel like it. We eliminate an outlier because there's a reason to eliminate that outlier. So we've mathematically identified 42 as an outlier, a number that lies outside the overall grouping of the data. But is it a bad number? Is it incorrect? Does it belong there? Does it not belong there? You know, if I tell you that these are ages of students in an elementary school, unless we're talking about that old movie Billy Madison, that 42 probably doesn't belong there. All right. If you don't know, if you haven't seen Billy Madison, it's a little dated in terms of you know, the cinematography and all that stuff, but it's a classic. It's worth looking into. All right, and very quotable. You probably have been or received a quote related to Billy Madison at some point of your life, and if you haven't seen the movie, you never knew it even happened. If you ever heard someone saying, "We are all now dumber for having to listen to, you know, something that you've said," then you probably are talking about a Billy Madison reference. That and Happy Gilmore. You know, the rest of the Adam Sandler movies, I don't know. They're not always necessary. One that was a surprising tearjerker was Click. That at the end of that, I was a mess. All right, but The Longest Yard.
That one's good.
Solid movie.
That one is so funny.
How was Uncut Gems? I haven't seen it.
Yeah, it's good.
But The Longest Yard is actually a remake of an older movie with. I just lost the name for a second. Smokey Robinson. Not Smokey Robinson. Smokey and the Bandit. Which one? Longest Yard. Yeah. I mean that one scene with Chris Rock in the cell that comes out of nowhere, and you're like, whoa, this just got dark really fast.
Sad, yeah.
You know, but aside from that, it was a good movie. Yeah. Okay. So technology wise, so what you're going to want to do is come up with an interval of outliers without doing any of this work. One way to do that would be to type the data in. All right, you use a table. All right, 2, 4, 5, and so on. 6, 7, 8, 9, 10. Data entry is like the worst part of statistics. All right. Okay, so all that stuff is in there. Then you could go one of two ways. One way is a little simpler, and we'll get to both ways before too long. But I'm just going to focus on the one of them. You go to Functions, Stats, and then select Stats again. All right. I don't know why they call this one Stats out of all of them. They're all involving statistics in some capacity, but we want to find the stats for X1. All right. And the reason it's X1 is because that's the column heading. All right. What it'll give us is the minimum, the Q1, the median, the Q3, and the max, and then you just pop it all into the formula from there. All right. Another way to do it, so just kind of stealing my own thunder a little bit, but it involves what's called a box plot. If you're not familiar, I'll get into like how to construct this in a future lesson, but for now, I'm just going to give you the avenue to get outliers very quickly. What you would do is you type in box plot. LOT. Box plot of X1. Then you'll see an option to exclude outliers. All right. So what you do is you just kind of toggle back and forth. So you see this box plot here. If there are any outliers, you can exclude them from the set. All right, so it's a visual inspection. So you look at the ordinary box plot with all the data points included. If you tap on Exclude Outliers, it'll identify with an open circle any points that are outliers. So if you just need the answer, sorry, I let it time out, but if you just need the answer, you can do that and then tap on that open circle, whatever the X value is going to be the outlier, right? You might have more than one outlier, so you'll have a bunch of open circles, possibly, but you can get the answers very quickly and easily using Desmos. All right, similar idea for the TI. It's just stat calc 1 like you were doing for, oh, I hit the wrong thing. Stat calc 1. After you put the data points in. So let me just pop it all in there. All right, so it's 2, 4, 5. You see, there's a little lag here. I don't like it. 2, 4, 5, 6, 7, 8, 9, 10, and 42. So quit out of there, stat, calc option 1, go to calculate. You see the mean and standard deviation, all that stuff. We'll talk about standard deviation like Friday. But if you scroll down, you see the minimum, Q1, median, Q3, and maximum. All right, so it'll give you the 5-number summary, and then you could use that with the formula. There's a box plot approach on the calculator, but we'll save that for another time. All right, I said minimize.